Welcome to aminacademy.com. In astronomy, let us discuss about Newton's great synthesis. It was the genius of Isaac Newton that found a conceptual framework that completely explained the observation and rules assembled by Galileo, Brahe, Kepler, and others. Isaac Newton, born December 25, 1642, Woolsthorpe, Lancashire, England, died March 20, 1727 in London. English physicist and mathematician who was the culminating figure of the scientific revolution of the 17th century. In optics, his discovery of the composition of white light integrated the phenomena of colors into the science of light and laid the foundation of modern physical optics. In mechanics, his three laws of motion, the basic principle of modern physics, resulted in the formation of law of universal gravitation. In mathematics, he was the original discoverer of the infinitesimal calculus. Newton's book explained these things clearly. Now we'll discuss Newton's law of motion. As a young man in college, Newton became interested in natural philosophy, as science was then called. He worked out some of his first ideas of machines and optics during the Prague years of 1665. When students were sent home from college, Newton, a moody and often difficult person, continued to work on his idea in private, even inventing a new mathematical tools to help him deal with the complexities involved. Now we'll discuss about Newton's law of motions. Newton's first law of motion, also known as the law of inertia, is a fundamental principle that describes the behavior of the object in the absence of external influences. The term law of inertia emphasizes the concept of inertia, which refers to the property of massive objects to resist change in their state of motion. This idea comes from the observation that objects naturally maintain their current state of rest or motion, resisting any changes unless acted upon by the external forces, which means any objects stay rest or uniform motion unless otherwise some external forces acting on it. The second law of motion describes the relationship between the force acting on a body and the resulting acceleration. According to Newton's second law, the force acting on an object is equal to the product of its mass and acceleration. That is, force F is mass into acceleration. Here, F represents the force, m is the object's mass, and a is the acceleration produced. Newton's third law of motion states that every action there is an equal and opposite reaction. When the two bodies interact, they apply forces on each other that are equal in magnitude and opposite in direction. This law highlights the concept that forces always occur in pairs. Interpretation of a Newton's law. Newton's first law is a restatement of the Galileo's discoveries called the conservation of momentum. The law states that in absence of any outside influences, there is a measure of a body's motion called its momentum. That remains unchanged. You may have heard the term momentum used in everyday expression, such as the scientific word. Newton's first law is sometimes called the law of inertia. Let's define the precise meaning of momentum. It depends on three factors. Speed, that means how fast a body moves, the direction of its motion. Third, the mass, the measure of the amount of matter in a body. Now, let us discuss about mass, velocity, mass, volume, and density. These are important terms in this concept. Here, mass, we know that mass. Here, mass is actual flesh on the body. Mass, that is in kg, ton, and gram, etc. Unit. Next is volume. Volume is a space occupied by a body. Is called a volume. It is in meter cube, centimeter cube, cube like. And density is mass over volume, kg per meter cube. Next, we will talk about angular momentum. A concept that is a bit more complex but important for understanding many astronomical objects is angular momentum, which is a measure of the rotation of the body as it revolves around some fixed point. An example is a planet orbiting the sun. Angular momentum of an object is defined as the product of its mass, its velocity, and its distance from fixed point around it which it revolves. If these three quantities remains constant, that is, if the motion of a particular object takes place at a constant velocity at a constant distance from the spin center, then the angular momentum is also a constant. That is Kepler's second law, consequences of the conservation of angular momentum. As a planet approaches the sun or its elliptical orbit, and the distance of the spin center decreases, the planet speeds up to conserve the angular momentum. Similarly, when the planet is further from the sun, it revolves more slowly. The conservation of angular momentum is illustrated in details in future videos. If it is property of the rotating body when by the product of the moment of the inertia and the angular velocity of the rotating object. It is a vector quantity which implies that the direction is also considered here along with magnitude. What is angular momentum? Here, angular momentum, we can see some more detail by using some formulas we can do. Here, which is a property of rotating body when the product of the moment of inertia and the angular velocity of the rotating object. Angular momentum, we can say L equal to angular momentum L equal to, it is a product of, it's a rotating body with the given product of the moment of inertia and the angular velocity I omega, L equal to I omega. That means angular momentum is equal to the moment of inertia of the body into angular velocity. Now, next, universal law of gravitation. Newton's law of universal gravitation states that every particle attracts every other particles in the universe with force directly proportional to the product of the masses and inversely proportional to the square of the distance between them. The universal gravitation equation thus takes from the form F equal to, we can say this F equal F gravity gravitational force F equal G into M1 M2 over R square, where F gravity is the gravitational force between the two objects, M1 and M2 are the masses of the two objects, and R is the distance between them. That is, F gravity is the formula G into M1 and M2 over R square, where G is universal gravitational constant. This equation tells us universal gravitational equation. Where F is the gravitational force between bodies, M1 and M2 are the masses of the bodies, R is the distance between the centers of the bodies. G is the universal gravitational constant. The constant of proportionality, G, in the above equation is known as the universal gravitation constant. This value is nearly about G equals 6.673 into 10 raised to minus 11 Newton meter square per kg square. The universal gravitational law can explain almost anything, right from how an apple falls from a tree to why the moon revolves around the earth. This universal law. So far we discussed about the great scientist Newton's synthesis and law of motion and universal gravitational law. We have done. Please subscribe our YouTube channel.